So in this video we've got something a bit different to the other videos we've done just recently on our trig identities, because we've got to find the size of the angle x in the triangle below in degrees. So the same question as the other previous videos, but in this one we actually have two triangles where this x, this unknown angle, is basically going to be a little bit more difficult to find. The reason being that if we look in this triangle, so if we look in this triangle containing the angle x, you can see that we only know one side length, so that the side length CD. And of course, if you're going to be finding the unknown angle, you're always going to need at least two side lengths. And so that basically means we don't have enough information in our little triangle here on the right, that I can shade in here in a second actually. So that's the triangle we're dealing with, and we don't actually have enough information just in this triangle to find the size of the angle. And so what we need to do is basically look over and start with our angle at 46 degrees over here on the left. So this is a 46 degree angle. I know the writing's a bit small, but this angle in here is 46 degrees. And the side length here is going to be 7.8. And so as you can see here, we actually do have enough information in this triangle because we've got one angle on one side. And so we can use this now to find the unknown side length in the middle, which is like the common side that we're looking for, which I can just put in black here. So that's the side BC. And so we're going to be looking for this side BC. And to do that, we're going to have to use our trigonometric identities, sine, cos and tan. So you can see here we've got SOHCAHTOA making another appearance. You basically need to use this in all the videos. If, you know, of course, if you have a different way of remembering the trig identities, that's also grand. I just use SOHCAHTOA. And so if we look at the sides involved here, we can see that from the perspective of our 46 degree angle, we're looking for the opposite. So the opposite angle across from the known angle we have. And we also have this hypotenuse of 7.8. And we know that's the hypotenuse because it's opposite the right angle. And so when you're dealing with the opposite and the hypotenuse and basically a known angle, that's going to mean that you're going to be having to use sine. So we're going to be using sine here. And so basically we set up this equation now using sine 46 degrees. So it's going to be sine 46 degrees on the left hand side, and then on the right hand side we have this unknown length for our opposite. So we're just going to call that BC because that is the name of the line. It's between the vertices B and C, so we're not going to reinvent the wheel on that one. But that's our unknown side, and then our hypotenuse, we know of course, is going to be 7.8. And this actually makes it really handy to find the length of the side BC because we can simply multiply across by 7.8 and then have our sine 46, of course, stay in there as well. And we can plug that straight in the calculator to find the length of the side BC. And the length of that side is going to be 5.61. And we're not dealing in centimeters here or meters. We're basically not given a unit of length here, so 5.61 is fine. So that's going to be the length of our side BC. And so basically what this means is that now that we have this length of 5.61, we do have enough information now to find our angle x, which once again is in the bottom right. So basically if we look at x now, we can see that the side opposite the angle x is going to be that side 5.61. And we don't have the hypotenuse at the top here, but we do have the adjacent, which is 9.2. And so we actually set up an equation now to find the length of the side x, or actually the size of the angle x, I should say. So we have our sides, we're looking for the angle. So because we're dealing with the opposite and the adjacent, we're going to use tan. So we have tan of x is equal to 5.61 divided by 9.2. And so of course we want to get rid of this tan on the left hand side. And so what we can do is just take the tan inverse of both sides, or move our tan over to the right hand side. And that is going to basically mean that we have x is equal to the tan inverse of 5.61 divided by 9.2. And so now we can simply plug this into the calculator to find the value of our angle x. And so the size of this angle is going to be 31.37 degrees. So that's the two decimal places, and so that is going to be it for this video.